Hi everyone. Let me start sharing the presentation and let me introduce myself. I would like to have in person today, but I could not do. I tried last week, but we could not make it. Thanks the organizer for inviting me, Fabio, Filipa, and the rest of the team. My name is Pepe, and I work in the xgeeks team at Grafana Labs, and they invite me to talk today about load testing, reliability testing, and xgeeks. Just a little about my background. I am an engineer who has recently moved to more technical content developer advocate or developer educator role, primarily because I felt that sometimes we spend a lot of time building the product and not enough time explaining how to use the product. So the talk of today, my intention is mainly to pick the curiosity on the people to try and to learn a little about load testing. So why we have built the tool, what it can offer, and there is also a demo. So I recommend if you want to try KCC, use the demo. I will go with a few examples here, but I think we only have 30 minutes, so I am not going to be able to present everything that I would like. So if anyone have any question, please raise your hand. I see there is a lot of folks there. So and I will answer. Let's start with the basic. So about the load testing, I like to see load testing like any other type of testing. We want to verify something. So and the difference is gonna be on the load part. So the load, when we do this type of testing, comes sometimes as a user. They ask, okay, can my website handle 1,000 concurrent users? Or other case could be like in terms of throughput. Maybe someone on the team has seen that a service, an endpoint start to struggling when there is some amount of request per rate, and we want to verify that one. But normally, like any other type of testing, just we need to consider some chains. And I would say like one of the most important chains with other type of testing is what we mark as a success. Normally we are used to run too many assertions, and if one assertion failed, then my test failed. But when we talk about load or production system, we move the time accept failures. So and this is something that we also need to consider. So in terms of like for example how we are measuring things, when we are measuring in performance testing, we talk about percentile, like P95, 95% of my requests should go below. There is a 5% of requests that is fine, that they go outside of this threshold, for example. Or for example, when we define SLOs in our system, we are always setting this error budget. So this seems that it could fail. So this thing we need to consider when we are creating our test. And it's gonna be very similar in terms of casing, like other type of testing is writing in JavaScript. Here is like what we call the scenario. We do a post to a product and we are doing a login. So something common to other type of tests. The difference is the load part. Here we are setting the load in terms of virtual user, 100 virtual users that they are gonna be running during 2 minutes. So testing the load. Two parts, just to show how also we could define the load in different ways. We have these two parts, what we call the scenario, the test. We have simply the load in terms of duration, and then we have here another concept, iterations. So iteration in xgeeks is just the execution of this function. So if we say we are gonna run 200 iterations, that means that we are going to be running 200 times this function. And then at load test, just to put a picture, it's going to be something like that. So xgeeks is going to schedule a number of views here that they are going to be continuously executing our function until the condition is not true. Either 1 minute has passed or we have executed these 200 iterations. So that is the basic, and this is like the demo environment. I'm going to show one example. Here is the source code of the project. So there is a KSIG folder, and there is many examples here for you to try. Normally there is a basic test, and then we are adding different features so that people could learn how to use that one. So let's see, my quick pizza app is running. It's very simple app, and we can order pizza, and we could get pizza recommendations. So let's see one load test here. So that would be like the basic test. And okay, first we could pass an environment variable where our website is. Then we set the load option that we have seen before. And okay, nothing complicated, just a post to get me a pizza. We do an assertion. Okay, let me zoom in a little bit. We do an assertion, check that the status is 200, the response status is 200. We log something. We are going to log the number of ingredients. And running this test, okay, I am here on the Quick Pizza project. Let me move to the Quick Pizza folder. And so KSIG is a CLI tool. I have downloaded my machine, and then I'm going to run this test like that one. So basic test is run, start executing all the view. We are logging in console. And then at the end, it's going to print some of the test results. I will comment that later on a little bit. So that is a basic execution of a test. So what next? Different type of test. So it is going to be very common that depending on the load that our system accepts, they are going to respond differently. This is why we tend to create different type of tests. Sometimes the scenario is the same, but the load is going to be different. Like some of the common ones are, I look at my average traffic and I want to replicate this type of traffic. Same for when we have a peak of traffic or high traffic. It could be a spike of traffic, which is very common too. For example, maybe most of our users come in the morning and then we have a spike of traffic. And then other type of common load tests are long duration tests. And then a test that we want to find the limits of our system, a breaking test. So we increase the load, and when the system fails, then we stop the test. So that is the different type of test. And then we could also be testing different non-functional requirements. The common one are how fast my system is. Other is availability, like synthetic testing is my system app. Other is like the reliability, normally giving in the error rate, is responding with error, or it could be any other product metric that we want to track. Other case, we may want to see how our system recovers from errors and to create a load test and to see how it performs during this time, or scalability. We may have set up some scalability policy. I want to create a load test and to see how my system scales, either up or down. Since to consider how we are building some of the system, that is not a call for building distributed system, but we found systems like that very common. And this has also changed the way that we do performance testing. Most of the time, or traditionally, we have been focused on end-to-end type of test. We start testing with like the public API, and then from there we make test the internal component. But now we have also more flexibility. When we have a testing tool that could do different type of testing, then we could be testing, like for example, a particular component, maybe just the database, that's the case, or maybe just an integration test of a few components. So the very common case, for example, is my queue system. I may have a queue, I want to measure how fast could process a number of items that I put on the queue. So different type of test depending on from where we want to start testing. And then before I go into core concept of API of KSIG, I would like to talk about some principles. We started building KSIG, I think 6 years ago. Mainly, developers were not happy with the 16 tool, so it was mostly about the tool that we wanted to have. And some of the principles that we started, they hold true too. So first one was like we are test as code supporter. As a developer, the two primary reasons that I tend to say is this type of testing is like any other type of testing. We are going to be starting a few use cases, and then we are going to grow over time. And we are going to be adding new cases. We are going to be reusing some of the modules that we have for some tests in other tests, and modularizing our code is going to facilitate that one. This is very difficult with codeless tools, but much easier if you have an scriptable tool. The other reason that we see very common is like with working with different teams. Maybe one team have a system, other team have a system, and you define an internal framework to use. So this was one of the principles. The other was we wanted an open source tool, and we wanted to give choices too. So there is KSIG can be executed in 3 different ways, either on my local machine. This is the command that I ran before, in a Kubernetes cluster to distribute the load across different machines, or in the cloud, our commercial product. And we wanted that independently of how you could execute your test, you don't need to change your test script depending on the environment that you are. For example, you may be using the cloud, but you may want to debug the test in your machine, and you should not need to change your test. The other principle here, I missed this one. The other principle is performance. So you should be able to create high load in a single instance. And what I wanted to highlight here, even you are going to code in JavaScript, the tool itself is writing in Go for performance reasons. You could import JavaScript library. You could not import Node.js library, for example, because it does not run in Node. And the last principle was extensibility. That came more when people start using the tool. People like the tool, and they starting to demand or to ask for, I want to use new protocol, I want to use KSIG on different way, I want to send my results to different places. So we realized that we were not going to be able to cover all the different cases, and we need to allow to the community to create plugins to extend the tool. Just to comment, a case we call KSIG extension, and they are writing Go code, but it's gonna provide a wrapper, a JavaScript wrapper for being used in our KSIG test. So if we click here, for example, we see many of the extensions, either some of them built by us, other by the community. So many different use cases. There is also in the Quick Pixel project, if you want to look at this one, I won't go in detail. Here on the extension folder, there is one extension. Here is the main code file, and then I am going to be able to use that one in my script. Okay, extensibility, and then a few concepts with a few examples of KSIG. So the first one that I wanted to show was like build metric, like the results. We have seen in the terminal, whenever the test finish, then it's going to present the aggregated information of our metric. Those are the metric, built-in metric, the one that KSIG automatically collect. For example, you have creating your test too many requests, so KSIG can collect the metric from those requests. We see here like data received, data sent, time spent during the connection. That is like the latency. And then we could also create our custom metric, and there is 4 types of custom metric. Like a trend metric is a metric that we want to store different values there. Like for example, this one, duration is a trend metric. We are collecting the response time, all the response time, and then we show the statistics. The other are rate metric. It gives me a percentage of a true or false condition here, like the checks. The other are counter. It's gonna just count things that we put on the metric, and then gauge it like the last metric. Let's see one example, and then so here metrics. So we import a module. Here the trend, the counter. We create an instance of the metric. We give a name outside of the default function, and then inside I could be using that one for adding the for the counter metric, or here on the ingredient for this trend metric that is gonna store the number of ingredients. So let me run this example, and we are gonna see KSIG run foundation for metrics. So the difference now is gonna be that at the end of the test, it's gonna print the information of this custom metric. Here we are, and here we have like the number of ingredients and the number of pizza. So that is about metrics. Next, is it the next? Yes. Next concept are assertion in KSIG. KSIG has two types of assertion. One check that are informative, and the other threshold that could define this pass-fail criteria in our test. And the reason of having two API for assertion are for the same reason that I say at the beginning. We are going to be accepting a percentage of failure. So may have many checks or many assertions in my code. It's going to run many iterations. Maybe I have 20 assertions running 1 million iteration, 10 million assertion. Because one is going to fail, I don't want my test fail. This is why there is two different APIs. So we have seen checks before, like that. It's going to pass just a condition. We give any name that we want. And then the thresholds are defined on the options. Here we have, and we need to give, like, for this particular metric, I want to check this condition. For example, the error rate of HTTP request, I want the error rate to be below 1%, or the 95% of the latency of all the requests should be below 400 milliseconds. So we could define threshold in any metric that KSIG will collect. Sorry. So more concept how we define the load. We have seen like the constant view. If we want to do a ramping, let me show in one example. So we could define using a stage here, and we could put any number of view that we want. And we could be doing some crazy things like different type of ramping. Our recommendation is to establish a simple ramping. You ramp up, a stable load, and then you ramp down. That would be like ramping view type of load. Then we could also set the load in terms of iteration, we have seen before. And the last are in terms of arrival rate. And arrival rate is the one that we will use if we want to set up a test in terms of requests per second. But KSIG cannot set up a request per second rate because doesn't know how many requests you are going to execute in your test. So the way that we could do is to, KSIG can set a number of iterations per second, like here, run 100 iterations per second. Then you may execute just one request, and then you are going to have a load test that do 100% request per second rate. So that is also one example, and there is more documentation about this case. The last point is multiple scenarios. You could be also mixing different type of scenario in the same test. Like here, I am running a scenario executing one function, browser read news, with one view, running 3 minutes. The other, I am running a big load test, 5,000 views, virtual user during the 3 minutes, just stressing the news API. So those are different concepts. Also about results. So how you could visualize in your testing results. There is different method. By default, it's gonna run on the terminal. It's gonna just show the aggregated data of the metric, like the summary. But you could also tell KSIG, please output all the metrics that you collect to any storage, and then from this storage to visualize your results. So there is many different output. Most of them are through different extensions, but you could also build your custom output. Let me show one example of how that would look like with our previous example. Here, so we run KSIG with the output option, and now, in this case, we are gonna run the basic example during 30 seconds, to a Prometheus instance that is right now my Quick Pizza environment. So if we see here, we have here running Prometheus and time, and if everything, so here we have now the metric of this test that is being executed. Also, the Quick Pixel environment has a Grafana instance with a custom dashboard. Here, so we have a public dashboard to visualize the result from Prometheus and to Kasich, and that is going to allow you to visualize the results. And here are a few widgets, so you could customize that for your different use cases. So this is the demo to show Kasich sending results to a different output. And what else? Okay, much more information on the docs. There is many more different APIs. And just to wrap up, where we are heading with the tool, with this extensibility for different use cases. So there is a few new projects. So one is to allow to do browser testing with Kasich. So there is a module, the experimental browser module, and this module mimic the Playwright API. So we are basically copying the Playwright API and implement those ones that are useful for doing performance testing. So that if you are using Playwright, you could easily import into a Kasich test. And then by default, Kasich is going to be collecting browser metric, and they will show also the web vital metric. So our suggestion is that you run a test with a few browser instance, and then you load test your backend, and you see the full picture with this setup instead of running maybe a test with 1,000 browser instance, because it's very consuming. It consumes a lot of resources. So that's it about browser testing. The other use case are, we talk about extensibility with extension, just testing a particular component. In this case, would be like a database. We are using one extension. We have in the setup function, we add a table. We close on the third function, and we are doing our test just inserting on the database and see the performance. So many different extensions for different backends. So you could be just focusing on, I'm going to see the scalability of this particular part of my system. And just the last project that we have been working are fault injection. So if we work with distributed system, well, we know that sim may fail. There is also all this chaos engineering discipline that tell you, okay, just embrace error, just experiment with error, and know that see how your system behaves. So we wanted to do two things. So we wanted to integrate with different tools, but also bring some capabilities into Kasich. So there is this project, the Disruptor, run only for Kubernetes system, and you could tell, please, to this particular service or to this particular pod, I want that you start throwing errors, so that now you could focus on what did happen to my application when a particular component fails. I am implementing a proper fallback logic, error logic, retry things. So that is, for example, here, inject an error on my xgeeks service. Or here there is another one that is, example, inject an error to my account API with a 10% of requests failing with 500 response time. And at the end, how you could be mixing all together. So you could be doing a test like this one. Let's do a test that try to see the browser experience from a user reading the news. We saw this case before. While at the same time, we are injecting loads to the API that we want to visualize, but then maybe also we want to inject an error to an account API and see how everything works together. Okay, that's all. Summary about Kasich. If you want to learn more, I recommend the documentation and starting with the Quick Pixel. There is many examples there. So, thank you, everyone.